Algebra 1, EOC Star Review, Exponential Graphs. On the top left, we see an example of a graph of exponential growth, y equals a times b to the power of x. On the exponential growth graph, we see that from left to right, the graph is increasing or going up from left to right. We're going to identify some key characteristics on the exponential growth graph. We can identify the y-intercept, or where the graph crosses the y-axis at 0, 1. We can identify the asymptote, which in this case we have a horizontal asymptote where the graph does not exist, and we see that occurs at y equals 0. So the graph gets really close to the y value 0 but never actually touches. We can identify one nice point on the graph. We see that the point 1, 2, if we go right 1 unit and up 2 units, that point lies on the graph. Domain, we know is all x values that travel from left to right. So even though we don't see arrows in this graph, we're assuming that this guy is continuing forever left to infinitely right. So we would simply say all real numbers. Range we know is y values. The y values, all my graph is above my horizontal asymptote at y equals 0. So we would simply say that all y values are greater than 0. Once again, they do not touch at 0, so we do not put an or equal to symbol. Also on the exponential growth, when we said this earlier, that when b is greater than 1, the exponential graph is growing or increasing from left to right. It's getting bigger. 2 times 2 times 2 times 2. It's doubling each time. On the right side, we see an example of exponential decay, or an exponential graph that is decreasing from left to right, going down. Y equals a times b raised to the x power is still our equation, but this time we see the b value is less than 1. We are decaying or decreasing. 1/2 times 1/2 times 1/2. We're getting smaller. We can identify those same key characteristics. We see the y-intercept again is at the point 0, 1. The asymptote in this case is at the same place at y equals 0, or horizontal asymptote, hoi, y equals 0. We can identify one point on the graph. Here we can go right 1 unit, but this time we only go up 1/2. It is decay. Domain, all real numbers from left to right, goes infinitely left to right, all real numbers. And range, we know is y values. All my y values are above the horizontal asymptote. We would say all y values are greater than 0. Now that we know some key characteristics, here's a second graph that we can identify if it's growing or decaying. First, we see the graph is going up from left to right, so this would be an example of exponential growth. On this graph, we notice that there's arrows at the end, so we would say that the domain from left to right is all real numbers. We can use this less than sandwich inequality. So x values need to be greater than negative infinity, but less than positive infinity. Now keep in mind, if it's a real world situation, you have to look at your endpoints on the graph to see if there's arrows. It may have a definitive start and a stop. So for instance, it could start at 0. You would say all x is greater than 0, but maybe it's less than. It only happens for 3 years. So it would be between the years 0 and 3. That's if it's a real world situation. Range, it's y values down to up. Here we have to identify on the exponentials, the key part is identifying where is that horizontal asymptote. Well, in this case, it looks like the graph gets really close, y value 4, 3.5, 3, but doesn't quite get to 3. So my horizontal asymptote is at y equals 3. So we would say all y values are above that horizontal asymptote, so y values are greater than 3. Once again, you need to identify the situation, the problem. If it's a real-world situation, it could be endpoints where it has a definitive start and stop. But this one has arrows, so we would say all y's greater than 3, it continues.